Okay, so we already discussed how to add complex numbers, subtract complex numbers, and multiply complex numbers. So now we're going to move into the fourth operation, which is division. So let's look at these three examples that we have here on our screen, and I want you to focus on the denominators. When we divide complex numbers, when dividing complex numbers, we cannot allow imaginary terms in our denominator. So the denominator should have no imaginary terms. So I want you to look at questions. Look at your denominators. First, let's talk about the denominators that we have here. So let's look at this first denominator. Okay, this is what we call a binomial because there are two terms. It's a complex number because there's a real number and there's an imaginary term. Anytime you have a plus sign in between two terms, that is a binomial. It can have a plus sign, it can have a minus sign. So the denominator of number 5 is what we call a binomial. The denominator of number 7, because there's a minus sign, is also a binomial. Okay, so let's look at that and compare it to the denominator in number 6. This is a monomial. And that's really important that you can tell the difference between the two. Okay, that's negative 2i. Those two terms are not separated with an addition sign or a subtraction sign, so therefore it is a monomial. So the way we divide will be different depending on if we have a binomial or a monomial in the denominator. When it's a binomial, we're going to multiply. So a binomial denominator we're going to multiply by conjugate. And that sounds like a really fancy word that's complicated, but it's really not. In order to find the conjugate, we flip the middle sign. That's all we are doing. Okay, so for question 5, what we're going to do, we're going to flip that plus sign and multiply top and bottom by 1 minus I. For number 7, we're going to flip that minus sign and multiply by 5 plus 12i. Okay, and I'm actually going to work through these in a second. I just wanted to give you a little bit of background. For the monomial, all we need to do to eliminate I is multiply by I. Okay, so the first thing you want to do when approached with a division question is determine what kind of term do you have in your denominator. Is it a binomial or is it a monomial? Okay, so now that we have that background, let's get started. Remember, you can pause the video, rewind the video at any time. So let's look at number 5. I have to multiply top and bottom by 1 minus I because that is the conjugate of my denominator. So let's do the numerator first. I'm going to make a box. And I have 6 minus I times 1 minus I. Let's fill in our 4 squares. 1 times 6 is 6. 1 times negative 1 is negative I. 6 times negative I is negative 6I. Now let's look at this 4th square. Negative I times negative I, I'm going to write this to the outside, is I squared. And if you recall from the first part of Appendix 7, I squared is equal to negative 1. So in this 4th box here, I'm going to put a negative 1. So now let's go ahead and combine our like terms. So let's start with our real numbers. So we have a 6 and a negative 1. So when you add 6 minus 1, you get 5. And now let's do our imaginary terms. Negative 6I and negative I. When you add that together, that's negative 7I. So let's put this to the side for now. And now let's do the same thing for our denominator. So in our denominator, we are going to multiply the 2 conjugates. We're going to multiply 1 plus I and 1 minus I. So we have 1 times 1, which is 1. 1 times I is I. 1 times negative I is negative I. Now let's look at this 4th corner again. Because we have I times negative I, and that is negative I squared. So in other words, that's negative 1 times I squared. We already know that I squared is equal to negative 1. So in this box here, we really have a positive 1, because negative 1 times negative 1 is equal to positive 1. So these cancel out because they're conjugates, and we're just combining our 1 plus 1, and that is going to give us 2. So our answer, and I'm going to write our answer for number 5 in red, is going to equal 5 minus 7I divided by 2. Let's look at number 6. Number 6 has a monomial, so we're multiplying top and bottom by I. So for the numerator, we have I times 2 minus I. And for our denominator, we have I times negative 2I. Okay, so for our first one, we're going to distribute. And that gives us 2I minus I squared. I'm going to put that in parentheses. So we have 2I minus negative 1. And that's going to give us 2I plus 1. So that is my numerator. Okay, so now let's do our denominator. There's an invisible 1 right here. So I'm just taking 1 times negative 2, which is negative 2. And then I times I is I squared. So we have negative 2 times negative 1, because again, I squared is equal to negative 1, so we have a positive 2. So our final answer for number 6, we have a numerator of 2I plus 1 and the denominator of 2. Okay, last question. We're going to multiply, because this is a binomial, we're going to multiply by the conjugate, which would be 5 plus 12i, and we're going to do that top and bottom. So let's start with the numerator. In the numerator, we have 13 times 5 plus 12i. And in our denominator, we need to make a box and multiply 5 minus 12i times 5 plus 12i. So let's distribute. Let's do our numerator first. So we have 13 times 5, that's 65. And then we have 12 times 13. Well, 12i times 13, that's 156i. Okay, so let's look at our denominator. Filling in our 4 squares, 5 times 5 is 25. 5 times negative 12i is negative 60i. 5 times positive 12i is positive 60i. And then I'm going to do this out to the side first. Negative 12i times positive 12i is negative 144i squared, which is negative 144 times negative 1, so that's positive 144. So our answer in our denominator, when we combine our like terms, these cancel out, and we have 25 plus 144. So our denominator is 169. So our answer, and I'm going to write that in green, has a numerator of 65, and again I'm doing number 7, 65 plus 156i all over 169. However, for those of you planning to take any type of math in college, you will be expected to reduce this final answer. This is the first time where we could actually reduce. When we look at these 3 numbers, the 65, the 156, and the 169, they can actually be divided by 13. So the answer, the best answer, is if you divide all 3 of those numbers by 13. Because if they have a common factor, you are expected to remove it. So that gives me 5. 65 divided by 13 is 5, plus take 156 and divide that by 13, and that gives you 12i. And then if you take 169 and divide it by 13, you get 13. So this would be the best answer.